If you've ever driven an electric car, you've probably noticed a few quirky little things most people don't talk about. There's that faint vibration, occasional odd noises under load, and lingering questions about the long-term reliability of the complex permanent magnet motors they use. But behind all that is a far bigger issue that rarely gets the spotlight. Nearly every EV motor today depends on rare earth materials, and China dominates the global supply. That kind of monopoly doesn't just raise eyebrows, it puts the entire EV industry in a risky position. But what if Tesla is quietly building a way out? Strong rumours suggest a major breakthrough is coming our next generation, water-cooled motor in development for the 2025 Tesla Model 2. This new design could completely eliminate the need for rare earths. Colin Campbell, one of Tesla's top engineers, even hinted at this during Tesla's Investor Day. As the world moves toward clean energy, he said, "The demand for rare earths is going through the roof, but not only is meeting that demand a challenge, the mining process comes with serious environmental and health risks. We think we can do even better. Our next drive unit, which still uses a permanent magnet motor, won't need any rare earth materials at all." If Tesla pulls this off, it could mark the beginning of the end for China's EV tech dominance. So hit that subscribe button and help Auto Intel reach 1,000 subscribers big, because what's coming next could reshape the auto industry. So, what's the real issue with current EV motors? Most electric vehicles today, including Tesla's Model 3 and Model Y, use permanent magnet synchronous motors, or PMSM. They're compact, efficient, and deliver excellent torque. But they have one major weakness. They rely heavily on rare earth elements like neodymium, dysprosium, and terbium. These elements are costly and harmful to extract. More critically, they're a massive geopolitical risk. As of 2023, China handled around 87% of global rare earth refining and over 60% of total mining output, according to the International Energy Agency. That means the entire global EV supply chain is effectively tied to one nation. It's a dangerous place to be. In 2023, China restricted exports of gallium and germanium, a clear signal that access to key resources can be weaponized. If the same happened with rare earths, EV production worldwide could be crippled. And then there's the price problem. Neodymium oxide prices more than doubled between 2020 and 2023, from about $45,000 to over $90,000 per metric ton. That kind of volatility wrecks supply chain planning and drives up costs. Environmentally, rare earth mining is a disaster. For every ton extracted, you get a ton of radioactive waste, 75,000 litres of acidic wastewater, and up to 1,000 tons of tailings loaded with heavy metals. In Inner Mongolia's Bayou region, China's rare earth hub, the damage is already obvious. Polluted water, radiation, and long-term ecological harm. In response, Tesla is reportedly working on a rare earth-free motor for the Model 2. If it works, it could help the company bypass China's monopoly, streamline production, and cut environmental impact. This could be the most important change in EV motor tech since lithium-ion batteries. So, what is a water-based motor? Instead of using rare earth magnets, this design uses copper coil electromagnetic induction to generate torque. It's cleaner and simpler. Copper is far more available than neodymium or dysprosium. Global reserves exceed 870 million metric tons, according to the USGS. At its core, the system features a sealed, high-pressure smart cooling loop using a water glycol mix similar to high-end data centers and liquid-cooled computing. This keeps the motor cool even under heavy load, improving efficiency and durability. Reports suggest the system operates at 2040 SI and holds temperatures between 50-80 degrees C, even during hard acceleration or uphill climbs. That's a major upgrade from older air-cooled or low-efficiency coolant systems. Unlike permanent magnet motors, which are bulky and hard to recycle, this motor is modular and easy to disassemble at end of life. Tesla engineers reportedly cut the motor's weight by up to 18% and reduced manufacturing steps by over 30% compared to Gen 4 drive units. That means cheaper, faster, cleaner production. The design draws from cooling tech used in Tesla's Dojo supercomputer and even hydraulic electric systems in heavy machinery. Some of the thermal management techniques were originally developed for SpaceX engine systems. Think this could be the boldest EV move since the original Roadster? Drop a water in the comments if you think Tesla's new motor could change everything. Now, let's talk about power. Leaks and industry sources say the 2025 Tesla Model 2 will feature a new water-cooled motor producing between 370 and 400 horsepower. That's wild for a so-called entry-level EV. Most compact electric cars sit around 150-200 horsepower. Torque is expected to exceed 500 Newton meters, offering impressive acceleration for daily driving and highway speeds. Early tests point to a 0-60 mph time under 5.7 seconds quicker than a Toyota Camry, and some Tesla Model 3 trims. This performance comes from a 400-volt electrical system combined with advanced water glycol cooling. Unlike air-cooled motors that throttle power under stress, this one stays at peak output even in tough conditions. No permanent magnets also means no cogging affect the jerky motion from magnetic resistance. The ride feels smoother and quieter, especially at low speeds. Internal tests show noise levels up to 40% lower than Tesla's Gen 3 motors. Plus, the motor is smaller and lighter, freeing up cabin and cargo space. Big wins for a compact EV. Tesla insiders claim the setup cuts about 60 pounds from the drivetrain. That boosts handling and range. And here's the kicker: it could power a car costing less than $11,990. That's huge, especially with today's compact EVs, averaging nearly $29,000. The new motor will also integrate with Tesla's Drive OS, which uses AI to adapt torque delivery based on terrain and driving style. That means tighter cornering, better traction, and a more refined driver-no self-driving required. And if you're enjoying this breakdown, hit that subscribe button. Auto Intel is your go-to for EV breakthroughs and industry insights. Your support keeps us going. Now let's tackle a big question. Can a water-based motor handle extreme weather? It sounds risky: water and electricity in freezing or scorching conditions. But Tesla's engineers have built in resilience through a smart coolant system. It uses a glycol-based liquid with nano additives that stay stable in extreme temperatures. Lab tests show it works down to 40 degrees F and up past 120 degrees F without boiling or losing performance. The system is sealed and pressurized, so there's no evaporation or contamination. Tesla claims it requires no regular maintenance during the car's lifetime. Smart sensors constantly monitor and adjust pressure and temperature. The software learns from your speed, elevation, and driving behavior to optimize performance in real time. Much of this cooling strategy is inspired by SpaceX engine tech systems that mean to perform flawlessly in extreme heat and vacuum. So whether you're facing icy mornings or desert heat waves, this water-cooled motor is built to handle it. Drop a comment with the first place you'd take at mountain pass, road trip, or city cruise. Now zooming out, is this the shift the world's been waiting for? For over a decade, China has controlled the EV supply chain, thanks to its dominance in rare earth refining. That advantage helped brands like BYD, XPeng, and NIO outpace Western rivals. Their lead comes from access to rare earths key to building high-performance EV motors. But Tesla's water-based motor could be the first serious challenge to that lead. By removing rare earths, Tesla breaks free from a vulnerable dependency. And they're not alone, for GM and Toyota are also exploring rare earth-free designs. If Tesla can scale this motor, especially in an $11,000 EV, it could trigger a global shift in EV manufacturing. It's not about cutting China out. It's about building flexibility, creating a resilient, diversified supply chain that's ready for the future. So what does this mean for you? First, cheaper vehicles. Cutting out rare earths could reduce drivetrain costs by 25%, making EVs far more affordable. Second, better range and performance. Lighter motors and smarter cooling mean more miles per charge. Third, lower maintenance. No magnets to wear down and fewer overheating risks mean a longer-lasting motor. Fourth, budget-friendly reliability. Whether you commute, road trip, or live on a fixed income, this new design works for real people. Fifth, true all-weather capability. It's tested for the extremes hot or cold. If Tesla's new water-cooled motor delivers, it's more than an engineering milestone. It's a game-changer for the entire EV industry. Would you trust a water-based motor over traditional magnets? Tell us in the comments. And don't forget to subscribe to Auto Intel. We're pushing for 1,000 subscribers, and your support means everything.